Hello, welcome to part 2 of Chemistry, Solids, Liquids, and Gases from the Science Whiz collection. Pressure puzzle. Here is a puzzle. There are 4 water fountains in a row. The water fountains at each end do not deliver much water when the 2 in the middle are in use. The fountains are all connected to one main water line. Does the main water pipe come in at A, B, or C? Mixing oil and water. Do all liquids mix together? Let's experiment. Pour water into a cup and food coloring. Pour vegetable oil into a plastic cup or empty food jar. Pour the water into a jar of oil. Stir with spoon. What happens to the oil and water? Oil and water do not mix. You can try to mix them together, but they will separate. Oil is lighter, less dense than water. Oil floats on top. Water is heavier, more dense than oil. Water sinks to the bottom. Can you change the density of a liquid? Yes. Here's how you do it. You'll need salt, raw eggs, spoon, water, and tall clear glass. Lower the egg gently into a glass, 2/3 full of water. Does the egg sink or float? To make the egg float, add salt, a tablespoon at a time. Stir. How many tablespoons of salt does it take to float an egg? The egg is more dense than the clear water, so it sinks. The egg is less dense than salt water, so it floats. The egg is less dense than salt water, so it floats. To suppose the egg in the middle of the glass, pour off some salt water. Slowly add clear water above the egg. The egg stays between the 2 layers and more dense salt solutions below, and less dense clear water above. Brain teaser. Sink or swim? Is it easier to float in salty ocean water or a pool of fresh water? What is density anyway? It is easier to float in salt water because salt has a greater density than fresh water. To understand density, let's do a thought experiment. Start with a tablespoon of water. Pour half of the water into another spoon. Are both proportions still water? Of course. What a silly question. What if you do it again? Divide each portion in half. Is each half of a half still water? Another silly question. What if you keep going? Divide the water in half over and over again into smaller and smaller portions. Is there some smallest portions into which you can divide water before it stops being water? The answer is actually yes. If you could divide a tablespoon of water into half about 53 times, you would have divided the water to its limit. You will be down to 1 molecule of water in each spoon. That's the limit, the end. If you could divide the 1 water molecule any further, it would no longer be a water molecule. It would be broken into atoms. Here's what a water molecule looks like. Sort of, if you could see it, which you cannot. It's so small. Let's play with the ideas of density and molecules. Find marbles, 2 cups, puffballs, and toothpicks. The water molecules: hydrogen atoms, oxygen atoms. Pretend the marbles and puffballs are molecules. Do each group separately. Which is more dense, A or B? 2 marbles, 1 marble. Which is more dense, C or D? C is 2 marbles, D is 2 puffballs. Which is more dense, E or F? 2 marbles, 2 marbles. Packing density, G or H. All marbles, and toothpicks. Salt water is more dense than plain water because the packing of the molecules is tighter and the atoms in salt are heavier. More dense things sink. Less dense things float. Trick with water skin. Floating a paper clip. There are other ways to make something heavy and dense float. If you drop a small paper clip into a cup of water, it will sink. Here's a trick what will make the paper clip float. Float a piece of paper towel on the water. Gently lay a small paper clip on top of the towel. Let the paper towel sink to the bottom. The paper clip is caught on the water surface. Water has a skin. This skin is strong enough to keep the paper clip from sinking. This skin is called surface tension. You can use surface tension to overfill a cup. Try it. Some insects use surface tension to walk on water. You can break the surface tension and sink the paperclip by adding a drop of dish soap. Try it. Flowing liquids down and up. A liquid will plots to the bottom of a jar, bundle to the lowest point on the ground, or fill the part of the balloon that's down, making water flow up. Here is a trick that makes water flow up. You will need cup with a small amount of water, paper towel, green food coloring. Fold a paper towel like this. Don't green food coloring onto the wet towel. Put the towel in the water. The green dot must be above the waterline. Watch the color rise. What color do you see at the top edge? This upward movement of coloring flowers. This upward movement of liquids through absorbent materials or small tubes in called capillary action. Let's color a paper flower with capillary action. You will need from your kitchen food coloring and a paper towel, water, paper clip, plastic straw. Find in the kit's loop. Fold a paper towel in half. Now fold the paper towel like this. Insert the red loop through the yellow plastic straw. You can use a straightened paper clip with a hook end to guide the loop through the straw. Hold the loop in place with a paper clip. Stretch the top of the loop around the folded paper towel. Be sure to add a lot of food coloring. Put a yellow straw into a cup at least 3/4 full of water. Wait, the water will slowly color the paper towel. You can vary the patterns in paper towels by adding different colors to the waste water over time. You just make water flow up. The water went from the cup through the loop in the straw and into the paper towel. Air is made of gases. You cannot see air. You cannot smell air. You cannot taste air. If you cannot see, smell, or taste the gases in air, how can you know the gases are there? Proving air is there. Here's a way to prove that air is there. You'll need a sink or bowl 3/4 full of water, paper towel, jar, or cup. Add food coloring to the water to better see the results.